It would explode and destroy all of New York City, parts of Connecticut, and New Jersey. This is one of the greatest mysteries in our physics. Betelgeuse, a celestial wonder gracing the night sky, is an iconic red supergiant nestled in the Orion constellation, captivating stargazers for generations. Recent updates from renowned physicist Michio Kaku have raised concerns suggesting that Betelgeuse may have finally exploded. How this explosion reshapes our understanding of stellar life cycles and the forces shaping our universe is a question of great significance. What implications does it hold for us? Stay tuned to find out. Imagine gazing at the night sky and spotting a brilliant star in the Orion constellation. Betelgeuse, also known as Alpha Orionis, is a significant star located at approximately 5 hours 30 minutes right ascension and 0 declination. It derives its name from the legendary Greek hunter Orion, recognized for its brightness. Orion boasts numerous prominent stars, with Betelgeuse being a variable star characterized by its distinctive reddish hue, ranking as the 11th brightest globally at a magnitude of 0.6. Notably, Betelgeuse is the brightest star in Orion, shining like a beacon on the hunter's shoulder. The name Betelgeuse originates from the Arabic word Yad al-Jawza, meaning the giant shoulder. In 1603, astronomer Johann Bayer bestowed the star with its special name, Alpha Orionis, signifying its status as the brightest star in the Orion constellation. Interestingly, despite Rigel now being recognized as the brightest in Orion, Betelgeuse retains its name proudly. Betelgeuse is a colossal star with a mass about 764 times greater than our Sun, making it a giant compared to our solar system. To put it in perspective, if the Sun were a tiny marble, Betelgeuse would be a huge basketball. Determining Betelgeuse's distance has been challenging, with estimates placing it between 500 and 600 light-years away from our Sun, a vast distance in cosmology. In terms of brightness, Betelgeuse shines with a super bright rating of about 6. Harvard University researcher Morgan McLeod notes that Betelgeuse's proximity and size make it one of the few stars scientists can closely examine using telescopes on Earth and in space. Telescope images reveal Betelgeuse's unique features, showcasing a surface distinct from our Sun's smooth appearance. Instead of a uniform sphere of extremely hot plasma, Betelgeuse appears as a collection of uneven boiling gas pockets, some comparable in size to small stars. Significant outbursts of hot material rise from Betelgeuse's core to the surface, resembling cosmic spring cleaning. One such shell is so massive that traveling at the speed of light would take 75 years to traverse. This process, known as surface mass ejection, SME, expels materials from Betelgeuse's outer layers, similar to the Sun's coronal mass ejections. Despite differing internal structures and processes, Betelgeuse, at a mere 10 million years old, is remarkably young compared to our Sun. Despite its youth, Betelgeuse has already exhausted the hydrogen fuel in its core, entering the latter stages of its existence as it transitions into the red giant phase. During this phase, Betelgeuse utilizes helium to produce carbon through fusion processes, showcasing a rapid evolutionary journey fueled by its substantial initial mass at birth. According to scientists, Betelgeuse began its cosmic journey as a blue-white type star, belonging to the most massive category of hydrogen-burning main-sequence stars. In the realm of stars, size directly relates to brilliance and intense heat. Larger stars like Betelgeuse shine brighter and burn hotter, but this also leads to faster hydrogen consumption and an earlier transition to the red giant phase. Betelgeuse's surface once reached staggering temperatures of up to 89,500 degrees Fahrenheit, a sharp contrast to our Sun's lukewarm 10,000 degrees Fahrenheit. As Betelgeuse consumed its hydrogen and began fusing helium, its outer layer expanded significantly, making it one of the largest stars we know, stretching over 700 million miles in diameter. Presently, Betelgeuse's surface temperature is around 5,800 degrees Fahrenheit, cooler than the Sun, yet it outshines the Sun by an impressive 7,500 to 14 times. In 1836, astronomer John Herschel observed fluctuations in Betelgeuse's brightness, leading to its classification as a semi-regular variable star with periodic changes and occasional irregular fluctuations, typically following a 400-day cycle and an approximate 1,000-day cycle. Betelgeuse exhibited an anomaly in 2019, deviating from its usual behavior. Recent conduct gained attention due to unpredictable changes. Historically, its luminosity oscillated following a consistent 400-day pattern, brightening to a magnitude of 1.3 and then dimming to around 2.8. These fluctuations were associated with the outer layer called the photosphere, which emits most of the star's light and heat. Convective motion in the photosphere, where heat moves from the interior to the surface through gases, causes variations in brightness over time. During the autumn of 2019, Betelgeuse experienced significant dimming by approximately 60%, marking a deviation from its usual pattern. The cause was a massive ejection of material forming an extensive dust cloud, obscuring our direct view. Although the dust cloud has dispersed, Betelgeuse hasn't fully returned to its previous state, and its 400-day brightness cycle has shortened to just 200 days. Betelgeuse's unpredictable behavior sparked discussions about the potential for an imminent supernova explosion. In a supernova, as the star consumes its remaining fuel, its core collapses, giving rise to a black hole while expelling outer layers at speeds of up to 25,000 kilometers per second. If Betelgeuse undergoes a supernova explosion, it would be a breathtaking display visible for several weeks, similar to the full moon. Due to its proximity of just 650 light-years, while star explosions are common, they're often too distant to be seen without powerful telescopes, making Betelgeuse's potential supernova a remarkable event for night sky observers. As stars evolve, their cores accumulate iron, eventually triggering a supernova. The most recent observable supernova, Supernova 1987A, occurred in 1987, approximately 168,000 light-years away. This event, visible to the naked eye, provided valuable insights into stellar evolution. The last recorded supernova before that was documented by Johannes Kepler in 1604, which outshone all other stars in the sky, even during the day, but had no significant effects on Earth due to its considerable distance. Betelgeuse, a star in the spotlight, is expected to undergo a supernova, and Miguel Monteros, a Betelgeuse expert, anticipates its brilliance to rival that of the full moon when the supernova moment arrives. In 2021, Betelgeuse experienced a dimming event similar to the 2019 phenomenon, with around a 60% decrease in brightness attributed to the presence of a cloud within the star's wind. The cloud concealed half of the star, causing a missing southern hemisphere in images. Following this dimming event, Betelgeuse abruptly increased in brightness by 50%. The cause of this surge remains unknown, leading to speculation among astronomers. Betelgeuse, currently 15 to 20 times the size of the Sun, falls into the category of stars predicted to undergo a supernova, signaled by its red hue as a red supergiant. While astronomers generally propose that Betelgeuse could go supernova within the next 100,000 years, a recent study by Hayuki Cio and colleagues from Tohoku University suggests it might be in a more advanced stage closer to exploding. However, there are differing opinions on the validity of this conclusion. Cio's team bases their assertion on Betelgeuse's pulsating behavior, regularly expanding and contracting with overlapping overtones. Although they don't predict an imminent explosion, they suggest it could happen within the next 1,000 years, challenging the longer timescales previously considered. The uncertainty surrounding Betelgeuse's timeline has captured the interest of astronomers. However, some scientists argue that stars like Betelgeuse can endure for more than 10 million years, a surprisingly short span for astronomers but astonishingly lengthy for those outside the cosmic realm. In their quest for hints about whether the bright star might become a supernova, astronomers observe changes in the star's color. In ancient writings, people described the star's color as similar to Saturn's yellowish shade, not Mars's reddish hue. This prompts the question, has the star's color changed? If so, it might indicate rapid evolution, suggesting a supernova could happen sooner than expected. This color shift offers a clue about the star's changes, aiding scientists in deciphering stellar events. Whether Betelgeuse undergoes this explosion on schedule or takes its time to give a stellar show and intensifies its final act, humanity will have a front-row view to witness the testament of breathtaking cosmic diversity. What would happen if Betelgeuse went supernova? The idea of a supernova appearing in Earth's sky has captivated people's imagination. New simulations help astronomers understand what we might see when Betelgeuse eventually explodes, expected within the next 100,000 years. Though uncertainty remains, Betelgeuse is about 500 light-years away, and recent research suggests a significant star must be within roughly 150 light-years to cause noticeable effects. Around 26 million years ago, an event of this nature may have played a role in an extinction event impacting marine life after the Permian era. If a supernova occurred in our cosmic neighborhood closer than 30 light-years, things could get dicey. Although Betelgeuse's supernova is not projected to directly threaten life on Earth, there could be certain atmospheric impacts. The explosion would emit a surge of ultraviolet radiation, potentially leading to a temporary reduction in the ozone layer. However, research indicates that any resulting ozone depletion would likely be minor and brief, with limited environmental implications. Immediately after the explosion, we would detect weightless particles called neutrinos, which are harmless to us. The star would rapidly become brighter, reaching a luminosity akin to the full moon's radiance within 1 or 2 weeks. Betelgeuse's brilliance would then wane over several months, gracing our daylight hours for about 6 months to a full year. As night descends, it would continue to be a visible spectacle for another 1 to 2 years before bidding us a final farewell. Unfortunately, Orion would forever lose its red sparkle, a twinkle etched into memory. Regarding the threat to humans, supernovas release particles known as cosmic rays, which can penetrate Earth's magnetic shield. However, except for the closest supernovas, the amounts would be relatively minor compared to other radiation we encounter. The supernova's dazzling finale wouldn't just captivate us. It would also produce radioactive iron, a cosmic signature found in Earth's ocean floor and even gracing the moon. This iron, born from a supernova blast 2 to 3 million years ago, was a mere 300 light-years from us. Fortunately, its proximity posed no major threat to life on Earth. Rest assured, such a nearby stellar explosion is a rarity, possibly occurring only once in a billion years. As speculation surrounds the potential appearance of a Betelgeuse supernova from our planet, astronomer Andy Howell from the University of California wasn't content with mere back-of-the-envelope calculations. Seeking precision, he enlisted the assistance of 2 ex-graduate students, Jared Goldberg and Evan Bauer. Their intricate simulations vividly portray the star's epic finale, acknowledging uncertainties while leveraging insights from observations of supernova 1987A, the nearest recorded instance of a star's explosive demise in recent centuries. These astronomers concluded that life on Earth would remain unscathed, but the cosmic spectacle wouldn't go unnoticed. According to Goldberg and Bauer's findings, when Betelgeuse ignites, its radiance will resemble the gentle glow of a half-moon, shining approximately 9 times fainter than the brilliance of a full moon. This mesmerizing radiance is projected to grace the skies for over 3 months. Recent studies indicate that Betelgeuse is approximately 724 light-years away from us, securely outside the potential danger zone. Nevertheless, the supernova could have intriguing consequences for Earth. Howell highlights that many animals rely on the moon for navigation and may be disoriented by additional bright objects. Astronomers themselves would face challenges, as the intense brightness would outshine telescopes and space observatories. To adapt, telescopes would need to capture the subtler, softer glow. Experts reassure the public that there will be sufficient warning if Betelgeuse defies expectations and goes supernova during our lifetimes. Earth's instruments would pick up signals like neutrinos or gravitational waves produced by the explosion, giving us a heads-up as much as a day before the event. Although this event is not likely to happen for another 100,000 years, Betelgeuse will eventually turn into a supernova, and the outcome depends on the materials that remain after the grand finale. We await Betelgeuse's potential supernova as scientists continue to refine their predictions and enhance their understanding of such stellar phenomena. Observations of similar stars in different stages of their evolution provide crucial data for modeling the life cycles and eventual explosive ends of massive stars. This data helps astronomers assess the frequency and impact of supernovae within our galaxy, contributing to our broader comprehension of cosmic events and their implications for both nearby and distant celestial bodies. The study of Betelgeuse and other supergiants also aids in the calibration of cosmic distance scales. Accurate measurements of such stars' luminosity and behavior help refine the methods used to determine distances to far-off galaxies, thereby improving our overall mapping of the universe. Additionally, supernovae serve as vital probes for understanding the synthesis and distribution of heavy elements, such as iron and nickel, throughout the cosmos. These elements play a crucial role in the formation of planets and life as we know it. In the meantime, space observatories are closely monitoring Betelgeuse and similar stars, employing cutting-edge technology to detect any signs of impending change. These efforts ensure that we are prepared to witness and study one of the most spectacular events in the universe's life cycle, enhancing our knowledge of the dynamic processes that shape the cosmos. As we look to the night sky, we can't help but marvel at the beauty and mystery of stars like Betelgeuse, knowing that one day, this brilliant giant will give us a display unlike any other, a cosmic show that will resonate through the ages.